the variable to compute the limit as x approaches 1 of the square root of x minus 1 over the cubed root of x minus 1. If we try to use direct substitution, we're going to get the indeterminate form of 0 over 0. So we know that strategy is not going to work. And we also notice that we have radicals in both the numerator and the denominator, so multiplying by the conjugate radical probably won't work as either. So we're going to try to change the variable. So instead of using the variable x, we're going to use a different variable like u. And so there's a few things that we need to think about here. Before we start to define the variable u, we need to think about what is another way that I could write the square root of x and the cubed root of x. Well, I know that I can write the square root of x as x to the 1/2, just from our properties of exponents. And so following that, I can write the cubed root of x as x to the 1/3. Now, sometimes you're going to have just an x term in the numerator, which will make things a little easier, but because we have a radical in both the numerator and the denominator, we're going to have to do this extra step, because sometimes you can just take a look at the most complicated exponent that involves x, like the cubed root of x, and make that u and be able to solve from there, but we're going to do things a little bit differently here. So what do I mean by that? Well, I'm going to try to see if there's some sort of common denominator that I can use between those so that I can come up with an alternate variable for x and then simplify those two using that. Well, I know that the lowest common denominator between 2 and 3 is 6. So I'm going to let my u value equal x to the 1/6. And by doing that, it's going to allow me to rewrite x to the 1/2 and x to the 1/3 using x to the 1/6. So what does that mean? Well, if I try to figure out what u squared is, I can write that in terms of my root x, or even in terms of my cubed root of x. So let's see what happens there. So if u is x to the 1/6, what would u squared be? Well, u squared is going to be x to the 1/6 times 2, or squared. So we multiply the exponents, and that's going to give us u to the 2/6, which will simplify to u to the 1/3. And u to the 1/3, or if you can even think about changing that back to an x here, our x to the 1/3 we know is the same as the cubed root of x. And so I can now write the cubed root of x as u squared. Now what happens if I cube u? So if I start with u and I cube it, what am I going to get? Well, I know that u is x to the 1/6. And if I cube that, knowing my properties of exponents, I'm going to get x to the 3/6, which simplifies to x to the 1/2. And I know that x to the 1/2 is the same as the square root of x, so u cubed is equal to the square root of x. Now, that's a lot of work right now, but I promise it's going to make trying to solve this limit a lot easier. So let's go and substitute in what we know about that. So what do I know? So I know the limit as now I'm not going to use x approaches 1 anymore because I'm changing my variables to u's instead. So if x approaches 1 is what I'm going to think about as the limit, what is u going to approach? Well, u is equal to x to the 1/6. So if I substitute 1 in for that, I'm going to get 1 to the 1/6, which is just going to be 1. So the limit as u approaches 1 instead of the square root of x, I'm going to write u cubed. So u cubed minus 1. And instead of the cubed root of x, I'm writing u squared minus 1. This looks a lot easier for us to solve using what we know about algebra and factoring. So I'm going to go ahead and factor this. This is a difference of cubes in the numerator. So this is going to be the same as writing the limit as u approaches 1 of u minus 1, u squared plus u plus 1. And the denominator, a difference of squares, is u minus 1 times u plus 1. I can see that I have the same term in the numerator and the denominator, so those two will cancel each other out. And I'm just left with the limit as u approaches 1 of u squared plus u plus 1 over u plus 1. And now if I substitute 1 in for u, I'm not going to get the indeterminate form, so I can solve for this limit. So I'm going to get 1 squared plus 1 in the numerator over 1 plus 1 in the denominator. 1 squared is 1, plus 1 is 2, plus 1 is 3. 1 plus 1 is 2. So the limit as x approaches 1 of the square root of x minus 1 over the cubed root of x minus 1 is equivalent to 3 over 2.